Welcome to problem solving for the fall 2012 term. My name is Don Allen. I'm at Texas A&M University in the mathematics department. What we want to cover here is some examples of the types of problems we'll be looking at in this course. Balance problems. On a recent radio episode of an automotive show, there was a puzzler. These are the trick questions that are asked about weighing the objects with a small number of measures. Like how many weights does it take to measure any weight up to 40 pounds or 40 kilograms. The weighing is to be done on a two-trace balance scale. These are very common and ancient problems, have been around for centuries, and we're going to look at some of them in this course. There's lots of math involved, and you'll see many problems of this type. One absolutely huge problem in math and its applications is to make sense of data by approximating it by some curve. It's almost always a line. What we're going to do is consider this problem, its origins, and how it was used to discover an asteroid, and then some various different ways to approximate data, which you can see in the picture of the little circles, by a line. And 4 of the 5 lines you can see approximate quite good, but one is terrible, and we're going to look at that. Infinity. What is infinity? This was resolved only about 125 years ago by George Cantor. Infinity is all about problems and paradoxes. For example, there are exactly as many even integers as there are integers, even though you might think there should be twice as many. But no, when you're dealing with infinity, things like this happen. In this course, we define infinity and look at many problems it causes and many problems it solves. How about a little geometry? Look at that figure there. It's a square. A, B, C, D is a square. And we know that those two small angles, ECD and EDC, are each 15 degrees. Show that the triangle ABE is equilateral. This is a problem in elementary geometry, but it takes a little challenge to solve it. Here's one that involves geometry and area and series. So imagine this figure below it. In the bottom half of the square you see 2 large circles. In the next quarter of the circle you see 4 circles, and the area you can see. In the next one we see 8, and the one above that we see 16. And now if you take the blank line above and divide that in half, and half again, you'll be able to put in 32 smaller circles, and so on. What is the total area of all the circles? Is one of the types of problems we look at. There are lots of these kinds of problems where you generalize and then understand the geometry, the area, and the series that you require to add all those areas up. Well, these are a sample of the type of problems we're going to be covering in this course. If you want to take it, contact me at the email shown below. Thanks very much, and I hope to see you in the course this fall.